Hello, this is C#Shark. This is a raw socket implementation of a network packet sniffer. So, this is currently written in C# and utilizes the WinForm API to do the GUI. Uh, so I'm going to briefly explain how I implemented this using raw sockets. And to explain that, I have to explain at a basic level what a network socket is. Uh, Most of the time, network sockets that people are using to write applications, they're going to be TCP or UDP sockets. A raw socket is a little bit different because the other two sockets I just talked about, they're protocol specific and they do a lot of the parsing and other things you need for networking for you. So what makes a raw socket unique is that it's assumed the application will provide that parsing and the responses needed for the specific protocol. Well, in our case, we don't really care about sending responses or doing any of what, let's say a TCP socket would need to do. In our case, we just want to intercept packets and see, what's going on inside them. So that's pretty interesting because it means that we're able to get all kinds of network traffic that's not necessarily meant for us. We're able to get, IGMP packets, TCP, UDP, all kinds of packets we can get. There is a limitation though, because this is using a socket API. The socket API is written above your firewall. So you're not going to see all the packets you could potentially see. To get around that, you can turn off your firewall. However, I wouldn't recommend that for security reasons. If we look right here, we can see that right now we're set up on our Ethernet 4 network interface, but we can modify or change what interface we're going to listen on. So I'm going to select the local host. So by clicking this, we can start capturing packets. And I have auto scroll turned on, so we're automatically looking at the newest packets added. So some of the interesting things I implemented during this was a paging algorithm. I noticed that whenever I get a ton of network packets, that my GUI application got very unresponsive, very slow, and it also made filtering packets very slow and sluggish. It took me a while to figure out actually what was going on with this, but I was able to optimize the GUI in multiple different ways. One of the ways is that I added a double buffer to the output of the grid view. The grid view is simply what you're seeing right here, which is displaying the network packets. Additionally, the more important improvement is I added a paging algorithm. So let's stop the scan here. The paging algorithm that I added, it works on on a page width of 100 packets. And essentially what happens is that previously I loaded every single packet 10 times a second to our grid view screen. So like this right here would load every packet 10 times a second to the screen, which is just horrible because right now we're only viewing 27 packets. So that just doesn't make sense that we're rendering all these other packets, and it just became incredibly unresponsive. So instead, I implemented paging, which allows us to load only a select amount of packets at a time. So in this case, we only load 100 packets to view, and then if, let's say I scroll up here, we're going to load the remaining packets. And I scroll back down, we go back to our original page. There's not many packets here, so there's only 2 pages. So if I scroll back up, we can see that, yep, we can get to the top and see that this is the original packet 0 that we intercepted. So we can apply filters post-mortem to this. So let's say I want to only have UDP packets. I can apply this filter, and then we can see that we're only looking at the UDP packets that we captured. Another interesting thing that we can do is that we can look right here and see during our run what source IPs, what destination IPs, and what protocols we observed. So if you want to learn more information about this or learn how the code works, you can click on that logo and I actually have this up on GitHub. So I definitely want to add and improve this some more. In the future, I hope to optimize this code. I also want to give more options to filtering. Um, I would also like to add network statistics so that you can actually read you know, what IP sources and destinations are most prevalent and what packet types are most prevalent. Uh, I would also like to recognize more protocols because currently we're only able to recognize three. Um, that is TCP, UDP, and IGMP. All the other protocols, I mean, you can still intercept their packets, but we don't do the fancy color coding, um, and we don't recognize the protocol name. We just give it the number that we parse from the IP header. Thank you guys for watching. That has been C Sharp Shark.